So let's continue from the last week. You can see, right? This is actually last week's question. Now, there is this heating curve. And I told you this week I will look into a little bit on heating curve, but we still have time. So not a big rush. I will just tell you briefly what is happening here. Whenever you see a graph like this for this topic, okay, you will see horizontal line, okay? So if you see two horizontal line like this, right? Okay, children, if you see two horizontal line, and then the temperature is increasing. Okay, there's an increasing trend for the temperature. Now, take note, this will be the melting process and this will be boiling. Only the horizontal line, okay? So what is happening here? Now, when you start heating, let's say a piece of ice, they're talking about water here. So definitely below 0 degrees, see 0 degrees is here, right? Okay, so below 0 degrees, the entire graph below 0 degrees is telling you the state of ice, how the temperature is increasing in this piece of ice here, for example. So it is in the solid state. So yes, solid state is reflected here. This is also ice. Okay. Now, when the temperature gradually increases up to 0 degrees Celsius, the ice will start to melt. This is the melting point. Okay. So this temperature, right? If I draw the line, my line not straight. Get my ruler. Okay, let me draw a proper line. Okay, can you all see? You all can see clearly, right? Can just let me know if you cannot. So this temperature, where you have the horizontal line, this is known as the melting point. Of course, now you're looking at the graph for water. It is very simple, 0 degrees, you know. But if it is an unknown substance, okay, you will not know what is its melting point until you can read the graph, right? So if you read off the graph, right, this first horizontal line, okay, that stays horizontal for some time, if you check, it stays the same, okay, at 0 degrees Celsius for 3 minutes. The entire duration was 3 minutes. So the melting process took 3 minutes to complete. After that, right, it has totally melted. So when it has totally melted, okay, let me use another color, right? So this is liquid water. So this whole range here, right, shows liquid water. Okay? Just now was solid ice. Let me write down solid ice in purple also. So here, solid ice. So solid ice is pointed to this section. Okay? Now, when the liquid water continues to be heated, so we keep adding heat to the liquid water, it will come to a point where you see a lot of bubbling, right? Correct? So if you're boiling a pot of water, a kettle of water, it will reach a certain point where you started to see a lot of big bubbles. Okay, the process is quite violent, right? Not. Okay, so that is known as boiling, and it will take place at a temperature here. In this case, it's 100 degrees Celsius, but that's also easy for us because we are familiar with water. So we always identify the boiling point using the horizontal line on the graph as well. So temperature stays the same during changes of state. Temperature stays the same, stays constant, also means stays the same when there is a change in states. I need y'all to turn on your video. Jensen, thank you so much. Jensen, turn on the video. Ananya, turn on your video. Yan Hui, Tammy, Ange, Louis, you have to turn it on. Okay, then I can see your face. Yeah, I almost forgot. And then later they will message me. You didn't tell your student to turn on the video. Okay, good. Thank you so much. Now, so take note. Temperature stays constant when there is a change in state. change in state meaning what? Solid to liquid, liquid to gas. Now, so I am actually referring to the horizontal portion of the graph. Now, at the horizontal portion of the graph, right? Also, you have to take note, okay? This is the range where we have, I don't want you all to confuse with the diagram below. Okay, so maybe I have to draw here. I think it's better if I draw on the line. So this horizontal line, right, is actually the place or the range where I see solid and liquid together. Okay, so during melting, okay, during melting, which is the entire horizontal portion from minute 2 to minute 5. So solid state and liquid state exist together. Can y'all see that? Just like I put a piece of ice on the table when it is starting to melt. I still see the piece of ice there. Maybe not the whole piece now, it's getting smaller. And I see water also, a puddle of water, maybe small puddle. So the two states exist concurrently together. Okay, so solid and liquid state, they exist together. Now, after melting has completed, temperature rises again. As you can see here, the purple portion, liquid water. And then when it reaches boiling, okay, imagine you can see boiling now. The liquid is boiling or the water is boiling. There's a lot of bubbles. What are all these bubbles? These bubbles are actually gaseous water, okay? Or I can say steam. So liquid and gas exist together. Liquid water and then the gas is actually steam. Steam is water in gaseous state. So during boiling, and it's the same for all other substances. During the melting process, during the boiling process, there'll be two states existing together. This is something that you must know because if you don't know this part here, it is going to cause you a lot of problem when you answer questions. Okay, so this is what I want to explain about the graph. After boiling has completed, no more liquid water can be seen. That means we boil off all the water in the kettle, that kind of thing. Yeah. So in a gaseous state, okay, we only have gas particles as shown in the diagram here. They are far apart, free to move about. Okay, so this is all gaseous. I want to stick to purple, so wait. Let me change. Okay, so this part here, right, is gaseous water. Okay, gaseous water. I can call it steam, but I like the word gaseous there. It's clearer that it's in the gas state. So far, so good. Any problem here? No? Do you understand the graph? Louis, you understand this part, right? You do, lah. Okay, the next thing they will ask is actually, why does temperature stay constant during the change of state? Okay, so the next question they can ask, write down somewhere and tell yourself this is something that you must know how to explain. Okay, why does temperature stay constant during a change of state? So this is something that we need to start exploring, and gradually we will. So temperature stays constant during a change of state, meaning either melting or boiling. Okay, so either melting or boiling, you must be able to explain. Now, at first, right, okay, when we talk about the solid ice here, okay, we take it out of the fridge. The solid ice does not melt immediately, no. It must increase its temperature first. So that ice will take heat from the surrounding, right? So it will always be taking heat from the surrounding, absorbing the heat from the surrounding, and the temperature of the ice gradually increase. So maybe this is like minus 5, and then it will gradually increase until it hits 0 degrees Celsius. At 0 degrees Celsius, if I put the thermometer still, okay, within the ice, that whole maybe bucket of ice, yeah, at 0 degrees Celsius, I will be able to see the thermometer reading stays the same. It's always at 0, but I can see the ice melting away. What is happening here? Okay, so the heat that is taken in, right? The heat that is taken in is not, let's see. I can't decide on the color just, okay? So what happened here is, I want you all to take note. I'm answering this purple question here. Why does temperature stays the same? It stays the same because during melting, the heat energy, because energy is supplied to it in the form of heat, right? So from the surrounding. So heat energy is taken in, not to increase the temperature of the ice, but to overcome the forces. What kind of forces? Remember, in solids, right? The forces of attraction holding the particles together are very strong. So to overcome the forces holding the particles in fixed positions, okay? So once these forces can be overcome already, the particles actually start to move over each other. Yeah. Oh, how was it, Tammy? Tell me. Okay. So this heat energy taken in does not increase the temperature of the ice. Instead, it is used to overcome the forces holding the particles in fixed position. That's why it explains really the temperature will stay constant. Quite easy, manageable lah. Good. I love to hear that. Happy for you. You know, your exam also like my exam, all of you. I will also start wondering, how to help. Is there anything you all need to ask me, etc.? Like Nikki will update me regularly about the revision also. Okay, so yes, I have the notes written here for you. I am preparing a very nice sheet of paper, right? With the graph, with all these notes inside as well. So not to worry, I'll be sending to all of you. So today, I just want to go into a little bit about how this graph should be read. How do you look at the information given by the graph? So far, so good. If you're okay, give me a thumbs up. Okay, good. Can we okay? Louise, okay or not? Louise? Okay. Ange, okay? Tammy is okay, right? Right. So for B part 2, they say describe the change of physical state of water at these temperature. So what temperature they are talking about? 0 degrees Celsius. So it was 0 degrees Celsius. That means it's changing from a state of solid to state of liquid. Now, actually, this shouldn't be described. This one should be state. State the change of physical state. Okay? Yeah, will be better. All right, so the next part now, describe the change that occurs at 100 degrees in terms of motion of the particles. How do the particles move at 100 degrees Celsius? Remember, I was telling you, right? Okay, at 100 degrees Celsius, the liquid is actually changing to the state of a gas. Okay, that is boiling, right? So at 100 degrees Celsius, you need to talk about the particles gaining sufficient energy. Okay, if you want to write down sufficient heat energy, even better. Okay, so the energy is actually used to overcome the forces of attraction between the particles. So liquid particles still have forces of attraction holding the particles close, though they can move around, right? But they are not free to move all over the place. Okay, it's still quite close to each other. Yeah, Nikki.
Does that mean that the particles, when become liquid to gas or solid to liquid, do they disappear or do they merge? Or how come like they're not total, like in the solid, there are total of 16 particles, then end up in the gas there's only 4. So where do the remaining go? Do they like disappear or do they get
I also agree with you. Okay, in this case, right, because of the way they draw it, okay, here there are 16 particles, right? After melting, should still have 16 particles, isn't it?